Hey folks, so we're going to talk a little bit about design here. It's going to be a little bit abstract, but hopefully a little bit useful. So here let's look actually at the title of the slide because I think it kind of summarizes everything. There's somehow a notion of having an ADT, right, or a new type, and then having a representation for it and having a structure for it. Now, in the previous slide decks, we talked about things like, well, in the previous slides, we talked about, about arrays, about heaps, about binary trees. And then there was this weird thing we did, right, where we said, hey, even though we're going to say, hey, a heap looks like a priority queue, so we'll use it to store a priority queue, but then, we're going to put in an array, blah, 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 blah. That was a little bit strange. So we're going to talk about that for a second. So here's our kind of our observations. So first of all, right, we have some sort of a type, a priority queue. A priority queue has some conceptual tasks associated with it. Here it's insert and deleting. And when we think about those tasks, they line up really well with the idea of a heap. So a heap is a data structure. And this data structure with a specific representation. Really, it's a binary tree. A binary tree that behaves a certain way because of the rules that are enforced upon it. Okay? So we have that, right? And so we have somehow this notion, right, I have my priority queue and I have my heap, right? So I have my overall problem solving and then conceptually how the data should be structured in order to solve it easily, right, or well. Okay, but then we have, right, this extra step, right, where we have this idea of a different structure, right? So our structure here is the notion of an array. So even though I'm going to conceptually think about storing or representing the data for the priority queue as a heap, I'm going to actually structure it as an array, right? So array normally is just these bunch of indices right next to each other, right? All of a sudden, I would say we're going to store a heap in there. And what that implies, right, is if I have a heap representation in an array structure, there are additional rules, right? And so in that previous discussion, we had things like these little formulas that let us jump up and down between parents and children. That's what we're talking about there, right? So there are some rules to store that representation in that particular structure, right? And we use that particular structure because it's fast, lightweight, easy to deal with, right? It's more performant than having a tree, right? A tree, with a linked structure will be difficult to manage. You have to worry about things like doing allocations for the different nodes, setting up the different links, all these kinds of things, right? It's a bunch of trouble. It's much more straightforward just to keep it inside of an array. So these are kind of three different levels here, right? Our priority queue, right, is represented as a binary tree, right, or as a heap. But then that particular heap or tree, right, is being structured, right, as an array, right? So the structure behind the priority queue, right, the data structure is an array, even though that array is being used to store a priority queue, to store a heap representation, right? So those are different things, right? Structure is not the same thing as representation, right? Structure is really, am I using an array, am I using a linked list? Representation is kind of semantics behind the scenes to say, oh, this data should be stored a certain way, right? Parents should be larger than children, right? That's my representation, right? Having that tree with that rule being enforced. And so these things come together in order to give us a fast way to implement some sort of abstract data type.